In the following few examples, I would like to show you how to compute the numbers and how to simplify the algebraic expressions by using the laws of indices. So let me begin with a simple example. I would like to compute the number 16 to the power 1/4 times 8 to the power negative 1/3. Okay. So in order to compute this number, we need to write 16 as 2 to the 4 whole power 1/4 times 8 as 2 cube to the power negative 1/3. And now we can cancel this 4 and 4 because both of them are in exponent, and we can also cancel 3 and 3 so that this number is reduced to 2 to the 1 times this number is reduced to 2 to the negative 1. So now we can combine these two numbers. So it's 2 to the 1 minus 1, and this is equal to 2 to the power 0, and 0 power of any number is always 1. So this 1 is actually this number 16 to the power 1/4 times 8 to the power negative 1/3. So in the next example, I would like to show you how to simplify the algebraic expression. Suppose we have an expression x squared times y to the negative 3 times x to the negative 5 times y cube. Okay, so in order to simplify this, so let me rewrite this expression in the form x squared times x to the negative 5 times y to the negative 3 times y cube. So now we can combine the term of x and we can combine the term of y. So x squared times x to the negative 5 is x to the 2 minus 5 times y to the negative 3 times y cube is y to the negative 3 plus 3. Okay, and this is equal to x to the 2 minus 5 is negative 3 times y to the negative 3 plus 3 is y to the 0. So since y to the 0 is 1 and you want to write this x to the negative 3 as a positive index, so that this can be written as 1 over x cube. So this is the simplification of this expression. So let me continue with the example. So in this example, I want to simplify the expression x cube over negative 27 times y to the negative 6 whole power negative 2/3. Okay, so in this expression we have negative 2/3 as a power of this expression inside the parenthesis. So this exponent is for both numerator and for denominator. So we can write this as x cube to the power negative 2/3 whole over negative 27 to the power negative 2/3 times y to the negative 6 to the power negative 2/3. So when we write the exponent negative 2/3 in the denominator, this exponent is for both negative 27 and also for y to the negative 6. Okay, so that's why we have this exponent for both negative 27 and y to the negative 6. Okay, so after writing this, we can now cancel 3 and 3 here. So in the numerator we have x to the negative 2 divided by, so this negative 27 can be written as negative 3 cube times negative 2 over 3 times y to the negative 6 times negative 2 over 3. Okay, and this is equal to x to the negative 2 in the numerator remains the same, but in the denominator 3 and 3 can be cancelled, so it is negative 3 to the power negative 2 times, so 3 times 2 is 6, so it's negative 2 times negative 2 is 4, so it is y to the 4. And this is equal to, so I want to write this x to the negative 2 as a positive power, so I need to bring in the denominator and negative 3 to the negative 2 as a positive power, so I need to bring it up. So negative 3 to the negative 2 is same as when you bring it in the numerator, it's negative 3 square whole over this x squared times y to the 4, and this is equal to negative 3 square is 9 divided by x squared times y to the 4, and this is the simplification of this number. Okay, so we use some laws of indices to simplify the algebraic expressions. So in the following examples, I would like to show you how to rationalize the algebraic expression that involve the radical sign. So example 4. So I would like to rationalize the denominator of 3 divided by 2 times square root of x. Rationalize means rewrite the expression without the radical sign. So here I have square root of x, and I want to get rid of the square root sign in the denominator of this one. Okay, so in order to do that, so I need to multiply and divide by square root of x in this expression. So this is 3 over 2 times square root of x, and I need to multiply by square root of x in the numerator and also in the denominator, because square root of x over square root of x is 1, so this does not make any difference. So but when I multiply the denominator by square root x, so in the numerator I have 3 times square root of x, but in the denominator I have 2 times square root of x times square root of x is just x, and now in the denominator there is no radical sign, so the denominator has been rationalized. Okay, so this is how we rationalize the denominator. Okay, so in the next example I want to again rationalize the denominator. So I have an expression, it's 1 over square root of x plus 5, and I want to rationalize the denominator of this one. So in order to do that, I need to multiply and divide by the conjugate of the denominator. The conjugate means I just change the sign in the denominator expression, so I need to multiply and divide by square root of x minus 5 and square root of x minus 5 in here. Okay, so once I write this one, so 1 times square root of x minus 5 is just square root of x minus 5 in the numerator, but in the denominator I have square root of x plus 5 and square root of x minus 5. If you multiply these two expressions, you get square root of x whole square minus 5 square, and this is equal to square root of x minus 5 whole over square root of x whole square is just x minus 5 square is 25. So if you look at the denominator, there is no radical sign, so the denominator has been rationalized. Okay, so in order to rationalize the denominator or numerator that involve the radical sign, please remember to multiply and divide by the expression that involve the radical sign. Okay, so in the next examples I would like to show you how to simplify the algebraic expression just by making the common denominator. Okay, so it's the example 6. So in this example I want to simplify 1 over x plus 1 over y divided by 1 minus 1 over x times y. So to simplify this, I need to make the common denominator in the numerator and also in the denominator. So to make the common denominator in numerator, so I need to multiply the first term by I need to multiply and divide by y in the first term, so that this 1 over x is changed into y. So y over x times y minus the second term, plus the second term is 1 over y, so I need to multiply and divide by x in the second term so that it changes into x over x times y, whole over in the denominator. So this 1 can be written as x times y over x times y minus 1 over x times y, and this is equal to, so I have x times y in the numerator, in the denominator of numerator, so that I have y in here plus x in the second term, whole over, so again I have xy in the denominator of denominator, so that so I have x times y minus 1. Okay, so this is equal to, so if you look at here, and so it's y plus x over xy whole over xy minus 1 divided by x times y. We need to change this into multiplication, so y plus x is same as x plus y divided by x times y. When you change this division into multiplication, you need to flip the denominator, so here xy goes up, so xy divided by xy minus 1. So now we can cancel xy and xy from numerator and denominator, so this becomes x plus y divided by xy minus 1, and this is the simplification of this expression. Alright, so let me stop here. Please, if you have any question, please don't hesitate to send me an email. I will try to reply via email as soon as possible. Thank you. So I would like to stop the video in here.